This video, we are going to talk about arc length. Arc length is basically just kind of a piece of the circumference. So crust, basically, on a pizza. So we were looking for a length on that. So there's two different situations that are going to happen. Here are the formulas, and let me kind of show you what we got. That and this right here is called a central angle. The central angle is either going to be in degrees or it's going to be in radians. That symbol is called theta, and theta just represents an unknown angle. So if your picture and information is in degrees, all you're talking about is, and they use S to represent arc length, that you're just talking about a fraction of circumference. So all you have to do is figure out what is the circumference and what is your fraction. So your fraction is always just whatever that central angle is out of 360. So if it was 60 degrees, then it would be 60 out of 360. If it was 100 degrees, then it'd be 100 out of 360. So it's just a fraction of circumference. All right, so that's basically your thought process. If it's in radians, which it could very well be, the only difference is your fraction is not out of 360. Whatever your angle is, that'll be in radians, is out of 2 pi. And then you multiply it by circumference. So fraction of circumference, fraction of circumference. So let's do one. So it says an arc length. So find the arc length of a sector formed by a 60-degree central angle if the radius of the circle is 30 millimeters. So picture-wise, so here's our picture. We're looking at a 60-degree angle, something like that. And we know the radius is 30. And we're looking to find the arc length. So our arc length is going to be a fraction, which is 60 out of 360 times circumference, 2 pi times 30. All right, so we're going to throw that into the calculator and let the calculator kind of do all the calculations for us. So we have 60 divided by 360 times 2 pi times 30 for the radius. Okay, and that gets us 31 point, and the directions don't say anything, so we'll just take it to 2 decimal places, so 31.42. So 31.42. All right, so that's how we go about finding it, and it just kind of depends on the situation. Sometimes you'll be looking for an angle, and so you'll know the arc length, and you'll know the radius, and it really just becomes an equation that you want to solve. So we'll just do a couple others. So it says find the arc length to the nearest hundredth. Okay, so we're going to go out 2 decimals. That is intercepted on the circumference of the circle by the figure with the central angle of pi over 3. So here's our picture and a radius of 10. So here's our arc length that we're looking for. This time they give it to us in radius or radians. So the only thing that changes is my fraction is not out of 360, it's out of 2 pi. And then we multiply it by, let's see, circumference. Radius is 10. So the nice thing about having it in radians is when you look at this formula and you set things up, that 2 pi and that 2 pi are just going to wipe each other away. That's actually going to happen every time. So really all I'm looking to do to plug it into the calculator is pi over 3 times 10. And then no idea, we'll let the calculator do the math on that. So pi over 3 times 10. So 10.47. centimeters. Okay. Now there was this other formula sitting here, and that formula is basically what happens down here. I don't like it because I don't know what I don't understand the pieces behind it just by looking at it. Because to me, I'm always going to think of a fraction of the circumference, and then I'm just going to naturally cancel out my 2 pi's each time. All right, so let's do, we got 2 more to do here. So it says find the radian value. So this time you're missing your angle but you know what your arc length is and you know what your radius is. And so we're trying to figure out that piece. So that's okay. We're just going to plug in what we know. So we know the arc length to be 12.5. The fraction is going to be pi over 3. Nope, that's the last problem. The fraction is going to be, we don't know the angle measurement, but it's in radians. They're asking for that. So that's out of 2 pi. And then times circumference. And our radius is 5. Okay, so here's our formula. So this time we knew this value, we didn't know the angle, still out of 2 pi because we're finding a radian, and there's our radius. So we still plug everything in kind of like normal. This time that's missing, and we know this one. But 2 pi is always just naturally cancel out. So we're looking at 12.5 equals 5 theta, if I kind of clean up the order to that. And then I divide by 5. So theta, which is our angle in radians, is going to be 2.5 radians. So if you divide that, that's what you get. Okay, so one last. It says, last situation is find the radius given a certain amount of information. So here's our arc length. Radius we don't know, but we know our angle is 3 radians. So 3 radians is not quite all the way across, so it's not 180 degrees. It's just shy of that. But we set up everything like we did before. So let me just kind of do the formula this time. So it's in radian. I know the angle because they told us that it's in radian. So I'll be doing this formula. So we know the arc length is 8.22. We know the angle is 3 over 2 pi times circumference. We just don't know the radius to it this time. So we're solving for r. Again, naturally, the 2 pi's cancel out, which is perfect. You have 8.22 equals 3r divided by 3. And our radius is going to be 8.22 divided by 3. So 2.74. And then it is 2.74 centimeters. Okay, and that was finding arc length.